Okay. So let's start, Priya. So this is our second lecture on group 16. Okay. The last time we had come up to I think electronegativity. Today we talk about allotropy. See, if you remember in the earlier nitrogen, phosphorus, arsenic, antimony, bismuth, we realized that bismuth does not form allotrope. Here what happens is you have oxygen, sulfur, selenium.
Nitrogen does not form allotrope.
Array, that is the mistake which students make. I told you. Nitrogen has two allotropic forms, alpha and beta. Check whatever you have written down. Is this clear?
I was reading today
Huh.
in the book it was written.
Which book? Which book I am asking?
Yeah.
No, nitrogen forms the allotropic form. In fact, I gave you the two allotropic forms of nitrogen. 1 minute. See, except bismuth, all other elements form allotropy. Solid nitrogen exists in two forms, alpha nitrogen having cubic crystal, beta nitrogen having hexagonal crystalline structure. So that's a mistake in NCERT book. Bismuth does not form A. Okay, so that is a revision. So when we are talking about allotropy, so here what happens is they have clearly given the distinct structures of the solid nitrogen. Then what is the problem? Then what happens? Allotropy, what happens is all of them show allotropy. So first point is all group 16 elements,
Try Google also.
What?
Which does not show allotropy. It's the answer nitrogen. It was asked also.
I will also send you some reference material, okay?
Yes, sir. No, sir, it was written in the textbook.
No, I'll show you the reference now. Why are you worried? So, huh? What happened?
I was not able to hear you follow.
Okay. So all group 16 elements show allotropy. All group 16 elements show allotropy. Is this clear? Now, what are the allotropes? That is very important. Is this clear? So, A, first when we come to oxygen, you know that very well. Oxygen, you have O2 and you have O3. B, what do you have? Sulfur exists as what? Alpha sulfur. That is monoclinic, rhombic, plastic sulfur, all that. So you have alpha sulfur. Then you have beta sulfur. Then you have gamma sulfur. We're going to discuss each one of these structures later on. Gamma sulfur, plastic sulfur, and plastic sulfur. That is the amorphous form. You have plastic sulfur. Then see what happens is selenium. Okay. Selenium exists in what? Red monoclinic and gray metallic. Red, what is the element? Selenium. Selenium exists as what? Red monoclinic, and gray metallic. And gray metallic. Is this clear? In amorphous form, what happens? Dark brown. So there are three. Dark brown. We have dark brown. Then we have vitreous red amorphous silicon. Red not silicon, selenium, red amorphous silicon. Red amorphous, it's not silicon. I don't know why I'm saying this name is the same, selenium. Selenium. Okay. Then oxygen, sulfur, selenium, tellurium. So tellurium has got what? That is metallic and non-metallic. So tellurium has metallic and non-metallic. Tellurium has metallic and non-metallic. Okay. Of course, polonium. Polonium is what? Alpha form and beta form. Alpha form and beta form. So any one, what you call, permutation and combination can be what you call a question over here. It is clear. So maybe this is something you have to know. Clear? Then when we come to next is oxidation state. So generally what happens is you have oxygen shows an oxidation state of -2, +2, that of course 0 and then +1. Is it clear? So it can, no, +4, sorry. It can show an oxidation state of generally +2 and -2, oxide and A. Now what happens is, in case of peroxide, it can show, see, in case of peroxide H2O2, this is +2, so this can show -1. In peroxide, it can show -1 and then 0, of course, 0 is elemental state, not a big deal. Then sulfur can show an oxidation state of what? Sulfur can show -2, +2, +6 also. You have got this compound, sulfur hexafluoride. only sulfur hexafluoride, only this hexahalide is stable. That's very important. Okay. So sulfur hexachloride does not exist. It is clear. Only sulfur hexafluoride exists. Then what happens? We have selenium and tellurium. They show oxidation state of -2. Okay. And last we have is polonium is a metal that exhibits +2. Now here comes the MCQ. Polonium, no compound of polonium, no compound of polonium, no compound of polonium shows what? -2 oxidation state. It shows +2 and the stability of +2 increases because of inert pair effect. It is clear. So that's the second point. That is stability of +2 oxidation state. Stability of +2 oxidation state in polonium. Stability of +2 oxidation state in polonium is because of inert pair effect. Because of inert pair effect. Inert pair effect. Okay. Then what else can we say? Yeah, this is all that we have to say about oxidation state. Come on, take down. Okay, so this was what do you call the end of physical, all the physical properties, oxidation state and all. Now we come to the chemical properties of group 16. Now we come to the chemical property. So when we are talking about chemical property, we have oxygen, sulfur, selenium, tellurium, polonium. Oxygen is quite reactive. It is clear. So what happens is action of, I'm not talking about action of air. Sulfur forms sulfur dioxide, sulfur, then further it forms sulfur trioxide. It's a very simple one. We'll come to action of acids. So I am on chemical property. So first is action of acid. So please try to understand, when we talk of acid, there are basically two types of acid. There are two types of acid. That is, HCl and dilute sulfuric acid is a non-oxidizing acid, whereas concentrated sulfuric acid, dilute nitric acid, and concentrated nitric acid, these are called as oxidizing acid. Okay, so what do we have over here? That they are unaffected. So first point is unaffected. Unaffected by non-oxidizing acid. So which are the non-oxidizing acid? I'm again writing the example. HCl and dilute sulfuric acid. I'm very clear. Dilute, not concentrated. Dilute sulfuric acid. Concentrated is an oxidizing agent. Is this clear? So what happens is with nitric acid, suppose if it reacts with dilute and sulfur is oxidized, so sulfur reacts with hot concentrated nitric acid. So here you have sulfur reacts with nitric acid. What does it form? It forms sulfuric acid NO2 plus H2. Sulfur, selenium, oxygen, sulfur, selenium. Selenium reacts with nitric acid to form HeSeO3. Now this is a slight difference. This is selenous acid. Sulfurous. See, here it is forming sulfuric acid, but here it will form selenous acid. H2SeO4 would have been selenic acid. This would be selenous acid. So there will be a change in the oxidation state, plus NO2 plus H2. So we take this as something which is odd, which can be, what you call, marked for remembering for the exam. Is this point clear? Interesting thing is the second one, that is action of alkali. Action of alkali, what do we have? We have sulfur, selenium, tellurium, all dissolve in alkali. See, now understand. Sulfur, selenium, tellurium, okay, they dissolve in alkali. There's a difference between dissolving and reacting. After they dissolve, do they react? That only sulfur does. So sulfur, selenium, tellurium dissolve in NaOH or dissolve in alkali. But, okay, sulfur reacts.
Beside, before He, have you written He medium?
Before? This is He2. Yes, He2. Yeah, you're right. He2. You're right. Aja, since you have, I'll tell you very frankly, while we were talking, I already checked up with the reference book. It's a very old reference book that we have. Okay, it does state about allotropy that The two end elements, nitrogen and bismuth, do not display allotropy unless active nitrogen is regarded as an allotrope. So there is something called as active nitrogen, which they consider as allotrope. So that is why we were talking that it does have allotropy. But bismuth definitely does not have. Okay. Now that is a debatable point. I mean, this is something, this is a book which probably, it's a book of my times actually. It's a singular book only for inorganic chemistry. So whenever we study, what we normally do is we keep a reference book for something. So if they ask which does not show allotropy, if nitrogen is there and bismuth is not there, then nitrogen will not show allotropy. But if nitrogen is not there, but bismuth is there, bismuth definitely does not show allotropy. Okay. Now, as I told you, where were we? Now, when we talk of the next one, that is sulfur. We were on sulfur reacts with concentrated solution of sodium hydroxide. And what does it form? It reacts with NaOH. And what does it form? It forms sodium sulfite, Na2SO3 plus A2Na2S plus H2. So what kind of reaction is this? Sulfur has an oxidation state of 0. Oh, we had a blue pen, so you can use that. So sulfur here has an oxidation state of 0. Whereas what happens in Na2SO3, see, SO3 minus 2 means X minus 6 is equal to minus 2, so X is equal to plus 4. So here sulfur has a charge of plus 4 and here sulfur has a charge of minus 2. So 0 to plus 4 is oxidation and 0 to minus 2 is reduction. So what kind of a reaction is this? So now how do you frame the question? How do you frame an MCQ in this? Sulfur reacts with hot concentrate to undergo disproportionation. It is clear. Oxidation, reduction, something else we can ask. So it's or even redox reaction. But then remember, when the same substance undergoes oxidation as well as reduction, we say it is what? It is disproportionation. So this reaction is disproportionation. So when the same substance undergoes oxidation as well as reduction, it's called as disproportionation. Is this clear? Now we have space here. So we can talk about hydrides. Compound with hydrogen is called as hydride. So hydrides. First, let us talk about hydride. All of them form corresponding hydride. Okay. All group 16 element. All group 16 element form hydride. All group 16 element form hydride. Is this point clear? What are they forming? We have H2O, H2Se, H2Te, and we have H2PO. Hydride. Of course, polonium is radioactive, so not much we are going to talk about. Water also has H2O2, the peroxide. There are no peroxides in case of the other ones. What are the properties that we are seeing? Now look at all the properties of A. First and foremost, what is the property that we have? H2O is a liquid, whereas all others are gases. Why is H2O a liquid? We are studying the earlier chapter, solution colligative property, extensive hydrogen bonding, because oxygen is the most electronegative element. So this is one thing. Then we talk about the bond angle, H, M, H. If you remember, I told you, As the electronegativity of the central atom increases, bond angle increases. As the electronegativity of the terminal atom increases, bond angle decreases. Is it clear? So here, as we go down, electronegativity of central atom decreases, so bond angle is decreasing. So for water, it's 104.5 degrees, whereas it is 92.1 degree. This is 91 degree, and this was asked once, that H2PO has a bond angle of 90 degrees. See, when it's 90, there's a huge amount of steric hindrance. 90 and 91, what happened? There's huge amount of what you call, not steric hindrance. And steric hindrance is very different. Steric factors, they are too close and repulsion will be there. So instability increases. If they are not stable, they're going to break down very easily. They're going to give out what? They're going to give out hydrogen. Anything which gives out hydrogen in any reaction will be what? A reducing agent. So reducing property. So what happens are, one more property is, only water is non-toxic. See, I'm looking at all the properties one stroke. Only water is non-toxic, whereas all others are gases are toxic. So which is in fact, water is potable and toxic with unpleasant odor. Huh? Let us be very clear. It is toxic with unpleasant odor. So same thing over here. Whereas water is the only one. Next, what we can say is, I told you about its reducing property. Okay. Now there is one more thing about boiling point. Huh? I'll write it separately over here because this is important. Why, you will realize. So when I talk about boiling point, okay, obviously H2O will have the, not boiling point, not boiling point, I'm sorry. The where it bears volatility. It's not boiling point, it is volatile nature. Volatility is what is in trouble. Water is a liquid, where all others are gases. So obviously they'll be more volatile. But when you come to volatile, what happens? It is H2O, obviously is less than H2S. But H2S is greater than H2SC, greater than H2TE. You understood? So H2S is a different behavior as far as what you call volatility is concerned. Is this clear? It increases from, so H2S has more volatility, then the volatility decreases mainly because of molecular weight. Okay. Now thermal stability, one more thing that also anyway we can discuss. Thermal stability, obviously I told you water is more stable. Water greater than H2S, greater than H2SE, greater than H2TE. So H2TE will be a good reducing agent. Is this point clear? So that takes care of what you call all the properties. Please take down.
None, sir.
Okay. So now what do we have is reactivity towards halogen. So this is a slightly lengthy topic. Okay, slowly we'll do. So we have monochloride, dichloride, tetrahalide, hexahalide. So which does not form. So which does not form is the question which we have to remember, because that is how the multiple choice questions can be framed. Okay. So when you're talking about halides of group reducing character, I told you the reducing property increases because it's connected to thermal stability. So H2TE will be the strong reducing agent, not H2PO, because polonium is radioactive. So we'd rather look at non-radioactive elements. So when we are talking about reactivity towards halogen. Okay. When we talk about, say, oxygen, sulfur, selenium, tellurium. Oxygen does react with fluorine and it forms a compound OF2. So general question that the oxygen difluoride. Here, normally they ask this question: what is the oxidation state of oxygen over here? Because we have always studied that oxygen has a charge of -2 in oxides, it has -1 in peroxide, it has -0.5 in superoxide, KO2. Alkali metals, first that is S block elements, we realize sodium, potassium, rubidium, cesium, lithium, sodium, potassium, rubidium, cesium. So after potassium, it can form superoxides. It is clear. But after sodium, it can form peroxide. So potassium, rubidium, cesium. And remember one more thing, cesium and francium are liquid metals. So these are questions are framed, So superoxide was -0.5. Here is this compound where oxygen has an oxidation state of +2. So this has been asked, this question has been asked many times. When we come to sulfur, so you have S2F2 is sulfur monofluoride, sulfur difluoride, okay? Then you have sulfur tetrafluoride and sulfur hexafluoride, okay? So here this is the point I told you. Okay, hexafluoride of sulfur is only with fluorine. It does not exist with other halogens. So sulfur hexachloride does not exist. Okay. Then when we come to selenium, selenium monofluoride, selenium tetrafluoride, and selenium hexafluoride exist. Then when we come to tellurium, tellurium tetrafluoride and tellurium hexafluoride exist. Polonium, no such. It is clear. So you can see how they can catch you. Na? You can see 1, 2, like here, polonium. So which tetrafluoride does not exist? So 1, 2, 3, and then 4. We can join this and make a question. Tetrafluoride of which element does not exist? Polonium does not exist. Okay. So this is sulfur monofluoride, sulfur difluoride, sulfur tetrafluoride, and sulfur hexachloride. Remember. Then what do we have with chloride? So what is important over here is, I have told you, chloride. When we come to chloride, chlorine monoxide, chlorine dioxide, and chlorine heptaoxide. It is clear. We have chlorine heptaoxide. Then with sulfur, what do we have? You have sulfur monochloride S2Cl2, SCl2, and SCl4. Automatically, SCl6 does not exist. Then selenium monochloride, selenium dichloride, and selenium tetrachloride. When we look at tellurium dichloride and tellurium tetrachloride. With polonium, yes, we have something. Polonium dichloride and polonium tetrachloride. We come to bromides. Then the stability of the halides will decrease from what? Fluoride, chloride, bromide to iodide. So suppose if we have sulfur monoiodide, that will be very less stable. Okay. So we are coming to that point afterwards. So we have bromide. With oxygen, what happens? So you have Br2O, bromine monoxide. Sulfur will have sulfur monobromide, sulfur dibromide. Selenium dibromide, selenium tetrabromide. Then you have tellurium dibromide, tellurium tetrabromide. Okay. Then you have this is tellurium, so oxygen, sulfur. Wait a minute, make the mistake. Sulfur dibromide, S2. Oh yeah, yeah. This was oxygen, then sulfur would have been here, then selenium. So selenium would be selenium dibromide, and we'll have selenium monobromide, selenium tetrabromide, then tellurium dibromide and tellurium tetrabromide, polonium dibromide and polonium tetrabromide. So can you see over here, when we talk of bromide, what kind of question can occur? This is sulfur monobromide. This is sulfur monobromide. Only exists in case of sulfur. So sulfur monobromide, the other monobromides do not exist. They have only dibromide. And in sulfur, one more thing is, you don't have a tetrabromide, whether the other three will show a tetrabromide. So here, the other way of asking the same question. See, when you have a data, how do you fiddle with the data to get a question? That you have to understand, that you have to remember. What happens when people look at this data, they just skip it in the textbook. I am teaching you how they are framing the question. Is this clear? So here what happens? Tetrabromide does not exist. Sulfur tetrabromide does not exist. Okay. Then when we come to iodine, okay. Then when we come to iodide, I'm sorry, I've taken this. Okay, I'll write it properly so that we can, otherwise it looks horrible. So here I can take sulfur tetrabromide does not exist. Then we come to iodide. So now things become easy. Okay, when we talk of iodide, I2O5 does exist. For oxygen, I2O5. Then we have for sulfur. What do we have for sulfur? Sulfur monoiodide. Okay. Selenium, nothing happens. You have tellurium. With tellurium, selenium, nothing happens. Tellurium, you have a tetraiodide and polonium tetraiodide. Okay. So here what happens is the main question. So this is the question that they ask. Stability of stability of what? Stability of halides decrease with what? In the sequence, fluoride greater than chloride greater than bromide greater than iodide. Just imagine if you take one of the same type, okay, S2F2, SCl2, S2Cl2, over that way, and ask which is less stable, okay, then which would decompose, something like that. That question can be asked. So please take down this. What is her name? Priya, if you put in Google allotropic forms of nitrogen, then there is the answer. Huh? There are two allotropes of nitrogen element. As we know that nitrogen is present in gaseous form, but the solid form of nitrogen has alpha nitrogen and beta nitrogen. So I am quite right.
If you put that which element does not show allotropy, then nitrogen is also the answer.
Bismuth is the answer. But here you can clearly say that I told you very clearly, see, don't argue. Okay, when there is data talking about that, the choice is yours. In the exam, you want marks or you don't want marks. As simple as that.
Yes,
When I'm telling you, see the question, you just now put the question, allotropic forms of solid nitrogen. Then you get that answer, that it exists as. Because yeah, obviously. But see, the fact that in the solid form, it normally exists as gas, but in the fact that it exists as this in the solid form in allotropy, that clears the question that there is an allotropic form. But bismuth does not have, even the books of, I told you, the reference books say that. See, NCERT books has had mistakes. That is why people have sometimes got extra marks in the exam. I am telling you. People have gone to court because of interpretation of answer in NCERT book. So it is not an absolute Bible. I'll get this sentence edited before, because we are live streaming. I'll stop here today for the simple reason is the next topic is a very big topic of 1 hour, which we can take tomorrow. So for those who are following me on the live stream, okay, the next lecture will be tomorrow at 6 o'clock. So you can join the live stream. Okay, I'll stop it over here for a simple reason is I have 10 minutes. So, but the topic that I'm going to discuss is 1 hour. So I need that much time. I don't want to stop a topic in between. So whatever I have to complete, I've completed today. So I'm stopping the live stream now.